Students, I'll start the previous class. Second, the previous class I had solved one problem from the tower when the ball is directly thrown like this. So this we have taken directly as a U, as a horizontal component. So we had taken this same as the main component. This was uy. We had taken as 0 because it was going exactly in the horizontal direction, and u was same as your ux. This was your ux, and this uy we had taken 0. Why? Because this was exactly at 0 degree. So this was a horizontal component. Now this second problem. Now the ball is thrown at an angle from a tower of height 20 meters. Same condition. Calculate first one, time taken to reach the ground. Second one, horizontal range. Then third one, final velocity before hitting the ground. The fourth one, time taken by the ball to reach maximum height. This is the question. If there's no angle mentioned, then you have to take like this straight and then it comes down. But now this is thrown upwards. So the diagram will slightly change. So this is your tower. This is 20 meters. Now someone is standing here and is throwing up at an angle. So with reference to this, then it is 30 degrees. It is throwing upwards at 30 degrees. So what is going to happen? So will go up. This ball will come at some point. It will reach at its peak, and then it will come down. It must be the ground level. So this is your u now. So it is initial velocity. The ball is thrown at an angle of 30 degree. Okay, from a tower of height 20 meters. Rest all we have to calculate. Now, always for initial velocity, I told you there will be two components. One is your ux. This will be your ux. Vertical component will be uy. Now this will not be 0. Why? Because it is going slanting. In the previous problem, when u was going exactly horizontal, this was a horizontal component. And this uy was 0 because it was purely horizontal, exactly in the x-axis direction. But whenever your ball is traveling like this, slanting, it will always have to come. So same way, now uy will not be 0, it will have some component. So that will be what? U sine theta, and this is your u cos theta. So let us calculate the components. Theta is 30 degree. Okay, at an initial velocity also you put on. In the question, just add at 30 meters per second. A ball is thrown at 30 meters per second. Just add to the question. So initial velocity u is 30. So this is the data I know. Now let us find a component. So, ux is u cos theta and uy is u sin theta. We'll calculate both the components. So this will be 30 into cos 30, 30 into sin 30. 30 into root 3 by 2. So this is 15 root 3. 30 into 1 by 2. Sin 30 is half. From your normal trigonometric table, you know the values of the angle. So we found the components of initial velocity. Now, what else we know? The distance. So this can be your range, how much it has covered. I will write all the data for x and y. Initial velocity u. So ux is how much? 15 root 3. Uy is how much? 15. Then final velocity. I told you Vx will always be equals to Ux. Whatever you get, wherever you check at any point, your final velocity, even here, your x direction will always remain same, x component. So that will be 15 root 3 only. Vy we don't know. Then acceleration Ax and Ay. Ax is always 0 in horizontal direction because gravity is always in the y direction. Ay is minus 3. Then distance or displacement. This is 20 meters, but the ball is falling downward. Sorry, x means this. So that is to be considered r. The r or x you can take, no problem. Distance along the y-axis, definitely it's the ball is falling downward direction. So downward displacement is always to be taken negative. This is minus 20. Why? Because downward. So this is all the data I know. These are always fixed. Ax will always be 0 and this will always be same as this. This is also fixed. Ay is also minus. Sx is nothing but a horizontal distance. Sy is nothing but a vertical distance. First question, time has been asked. So whichever data, any kinematic equation you can use, try to find a time. So you can use distance formula because we already know the distance. Which distance we know? Sy we know. Initial velocity also we know. So what we'll do is, we'll take y everywhere. There are two options. Everywhere you can take x, or everywhere you can take y. If you take x, we don't know r. So that will be a problem. But if you take this, all the data you know. This we can take as -10. This also we know. This also we know. V is anyway not there in the formula. Our aim is to find a time. So u is how much? 15. Or first we'll write everything in terms of y. So this will be uy into t, ay into. Now substitute. Sy is -20. This is 15. I'm taking it as -10. And this. Bring everything on one side. So for that -15t. There's a t square. So bring everything on one side. So this will be pi t square -15t -20 equals to 0. All the terms I brought on one side. So everywhere common is 5. So we'll divide throughout by 5. So I'll get t square minus 3t. Throughout the equation, I divided by 5. And now we'll find factors of this particular equation. Factors of -4. 4 ones are 4. So -4 and 1. So t minus 4 equals to 0, or t plus 1 equals to 0. So t is 4 or t is -1. Time can never be negative. So -1 we can discard. We cannot get time as negative. The only option is t is 4. We found a time. So time taken is 4 seconds.
Teacher, here we can take gravity as positive, negative, right?
Yes.
Okay.
-10 I took. Yeah, no?
Yes. T will be 4 seconds. That is not clear. So first part is done. We got the time. Then second is, we'll find a horizontal range. Horizontal range means we have to find s of x. So for the same formula, now we'll have to find, this is the main formula. Now we have to find the horizontal range means everything we'll have to write in terms of x and put the value, find the value of s of x. Why? Because this is your s of x, horizontal. So in this formula now, this is s of x. S of x will be r, that is the horizontal range. Ux is how much? 15 root 3. Time is 4. This will be 0. Ax is 0. R is how much? 15 4s are 60 root 3. This part will become 0. The second part is done. We got a horizontal range. Now we have to find the final velocity before hitting the ground. Means basically we have to find V. V means already one component we know. The other component we have to find. That is Vy. So use any of the formulas and try to find Vy. You have many formulae now. You can use this formula, you can't use because this doesn't have V in that. So either the first one or the third of the kinematic equations. The first one you can use Qt Q plus C. So anyways we have to find Vy. So the whole formula will replace it by Vy. There's no point putting Vx because Vx we already know. So Vy we have to calculate. So this also will become Vy, Uy, Ay, and Uy value we already know from the table is 15. Ay is minus 10 and time is 4. This is Vy. So therefore your entire velocity is always Vx plus V. Add both the components. Vx we had got as 15 root 3. Just put I cap just because it's x, and this will be, so that's your velocity. In case you want to know its actual value, this along with the direction. Then you'll have to find the magnitude. This is in vector form. This is the actual value, or also called as speed. This will be 15 root 3 the whole square minus 25. And then you calculate. So this will be 15 square into 3. Root 3 square will give you 3. This is 625. Then calculate 15 square and multiply by 3. So it will be 225 into 3. 675 plus 625. Around 36. So this is your velocity in terms of vectors and in terms of magnitude, other value. Basically, you have to find x component you will already know because it is same as your ux. Y component we can find using this formula, and then we'll get. The third part is done. Now, last part, find the time taken by the ball to reach maximum height. Maximum height means here, when it reaches its peak. At maximum height, can anyone tell me what will happen to the velocity? Vx will always remain same. Whether you check here, now this is at the maximum height I am trying to check. Maximum height. So can anyone tell me what will be the vertical component over there?
When the ball reaches maximum height, what happens to the velocity of the ball? Why does it?
Zero.
Yes,
Zero.
yes. So this part will be Vy is always 0 at maximum height. So you calculate. Use the same formula now. This you can use. So we know this is 0. So we'll use Vy. This will be Uy, Ay, and T. I am used to calculate time. All this data we know. Uy also I know Vy is 0. Uy is 15. Now you can't use T, the S4. That 4 was to reach the final point. T is here now. This time we are checking at maximum height. T will be different at different points. First, what we had calculated, 4, what we got was for the whole thing till we reach here. Now, this is at this point when velocity is 0. So, that is the time, what is how much seconds it is? Minus 15. So, 3 by 2 it will be, this is 1.5 or direct 1. So, time is 1.5 seconds to reach maximum height. Any doubt in this problem? You can ask. A ball is thrown at 30 meters per second at 30-degree downward. Covers a distance from base of the tower. Find height of the tower. So now what is happening is from here, from this point, it's directly thrown downwards. So it will come something like this. And what angle? At 30 degrees. Like this. And it covers a distance of from the base of the tower to this 25.9 meters. And start thrown at 30 meters per second. So this is all the data we know. We have to calculate height of the tower. So right now Sx is given to us. We have to calculate Sy is how much. Or basically range is given to us. We will write all the components quickly. Now the components will be like this. If this is the arrow, it will always have a x component, it will always have a y component. So ux will calculate. So 30 into cos 30. So ux is initial velocity is 15 root 3. Same way calculate uy. It's in the opposite direction. So uy will have to take minus downward. So uy is minus. So we got ux and uy. In the previous problem, I had calculated separately and then put here. I have directly calculated here in the table. So ux is 15 root 3, uy is minus. Vx will be same as ux. Vy we don't know. Acceleration is 0. And last one, Sx which is equals to r. Sy we don't know. So this is all the data which we know. My aim is to find the height of the tower. Before that, in order to find the height, the formula is S is equal to ut plus half at square. So definitely we have to find Sy now. So everything we'll have to take in terms of Sy. But if you see, we don't know the time also there. It will be becoming difficult to calculate. So what I'll do is, if like this type problem comes, no, whenever there is range, no, on the top of the page you write and keep the range. There's a shortcut formula. Directly you can calculate the time. R is always equals to, we have already derived a formula in terms of sine theta. But suppose you want to know in terms of cos theta, this is the shortcut formula. U cos theta into t. U means definitely at which speed it is going. So this is horizontal distance, so this will be ux. Or directly, this normal ux. This whole thing is a ux, which is equals to u cos theta. Why it is nothing but, from where did I get it?
speed is nothing but distance upon time. We already know speed is distance upon time. It's always speed into time will be your distance. Speed is nothing but similar to velocity. Okay, in terms of velocity, it is nothing but we are talking about horizontal distance. The horizontal distance will be Sx, and this will be t. Sx is nothing but your range, this whole r, and ux is nothing but your u cos theta and t. Basically, it means that. So that is how I get that formula. Speed is distance upon time, or velocity is displacement upon time. Displacement is nothing but Sx, and velocity is nothing but ux. So directly you can remember this only formula. So r will be u is 30 meters, 30 meter per second. This is what 30 degree. R is given to me as 25.9. If you calculate this now, root 3 is 1.7. I told you already to remember that value. Root 3 value you have to by heart and keep because it becomes easier. Many places you'll come across this root 3. That is 1.73. If you multiply 1.73 into 15 now, you will get 25.9. Then you take this because they have given you only a value such that it will always cancel with this. So t is 1 second. Now take this formula. Sy is nothing but uy t plus half ay t square. Put your t value and calculate Sy. Or you can now take Sx also. Sy again will come as this, no? Oh, no, it doesn't matter. You can still use. So this will be u. Uy was how much? Check in your table and substitute. So this is minus 15 into 1 minus 10 into 1 minus 15 minus 5 minus 20. Why did I get minus? Because the ball is coming in downward direction. So automatically your Sy will come negative. The height of the tower is minus 20. Oh, this means only it was in downward direction. So while writing the final answer, don't write minus 20. Height of the tower has been asked. So write in positive. Why this minus came? Just to indicate that the ball is coming in downward direction. But if height of the tower is 20 meters. So this is how we have to calculate in case this is given and you have to calculate the height. Prove that R max is equals to 4h.
prove r max is equal to 4 times the height. Now this is what maximum range, and this is your height. H means r max means your maximum range, and h means your height. So we have to prove this is 4 times your height. Now for maximum range, we have already given you the formula r max. So this will be the proof. We know that r max is what? V square upon g. We had already calculated that. And for which angle we had got in the previous class, we had already proved. At theta is equals to 45 degree we had got. So this is the data we already know. So the same data we'll use for height and calculate what becomes the height. So we have to know that r max is v square upon g at theta equals to 45 degree. Now height formula already we know, v square, sorry, u square sine square theta upon 2g. So we'll check what is the height for maximum distance. It means basically what? If you are throwing a ball, when can this distance become maximum? The ball will cover maximum distance if you are throwing it at 45 degree. And what is the height? Relation between the height and the maximum range for that particular ball. So definitely theta will remain same for r max also and height also. So theta you put as 45 here. So definitely sine 45 you know is nothing but 1 by root 2. So directly I'll write here up. Now there's a square term. So we have to write square. So what we'll get? Therefore h is equals to u square. Square both the terms. So 1 square is anyways 1. Root 2 square is 2. Nothing there, it means it is 1. So this will reverse. So what will get? U square upon 4g. Now compare it with r. Just 4 you can keep it at the side. See, this you keep it as equation 1, this you keep it as equation 2. So put u square upon g equals to r from 1 in equation 2. So this part is nothing but r. H will be nothing but r upon 4. So r you keep here, 4 you take on the other. So r is 4 times h. So this is the, so this was all about the range and projectile motion. The last part that I'll do is some rain problems. I'd seen in one of the model paper. They are based on the relative velocity. I'll just quickly finish with the rain problem, then end with the chapter. So this is based on relative velocity. You have to remember, this is the formula. Velocity of A with respect to B is always velocity of A with respect to ground, velocity of B with respect to ground. This is the formula which you already know. Now over here, whenever rain problem, it is about holding the umbrella, in which direction the umbrella we should hold whenever there is a rain which is falling at a certain speed. Okay, so before starting, just write and keep note, umbrella to be always hold in the opposite direction. Okay, or later I'll give. If rain is falling downward, that's obvious, no? Downward, so we have to take it in the opposite direction. If rain is falling in the downward direction, open the umbrella in upward direction. Why I'm giving you this? While solving the problem, you'll come to know. If your vector is coming this side, no, your rain vector, then your umbrella vector will be on the opposite side. Now, practically thinking, obviously it makes sense. You'll think, why am I telling you? Because whenever rain is falling downwards, obviously we have to open in the up direction. The umbrella will always be the opposite direction against the velocity of the rain. In opposite direction. If rain is falling this side, then you will see how we have to open the umbrella. So the first one, I'll directly draw in terms of diagram only like this. So this rain is falling at 40 kilometers per hour. You are standing here. Okay, this is the person. And now we have to see in which direction he has to open the umbrella. So we'll calculate the relative velocity first of the sorry of the rain with respect to men. So as per the formula, this will be obviously velocity of rain with respect to ground minus velocity of man with respect to ground. Over here, this is slightly different because here we have to mention the direction also. In previous this questions, we used to not write in terms of vectors. If you want to always write in terms of direction, we'll have to mention I cap, j cap here. Now, can anyone tell me what is velocity of rain with respect to ground? What is velocity of rain? Look into the diagram and then tell me.
-40.
Yes, very good. This is -40 because this is coming downwards. or it's coming in which direction? It's coming in the negative y-axis direction. Upward means always positive y-axis. So if you have like this, suppose your normal graph, so it's like following this side, negative y-axis. So that's why it will be minus 40. And y-axis, vertical direction means you'll have to indicate J now. Okay, because for direction also we have to mention. This is minus. What is velocity of man? He's not moving at all, fixed position. So velocity of man with respect to ground?
0.
0. So velocity of rain with respect to the man is minus 40. So we draw, represent in terms of diagram. If this is your positive x-axis, so your vector will come this side, minus 40. Already we are marking this side, so you just have to write 40j. So this is of the rain. So obviously this will be your umbrella, exactly in the opposite direction. So they will ask you what is the velocity of the rain with respect to man and in which direction you have to hold the umbrella. That will always be. So in terms of angle, if you want to write, it will be 90 degrees. At an angle of 90 degrees. So umbrella, you write it in your own words, okay? You have to hold the umbrella at an angle of 90 degrees. So this is the first case. The second problem, similar thing. This is falling at 40 kilometers per hour. But now the person is moving on a vehicle or a trolley, suppose. Moving at 30 kilometers per hour. This is the man, this is the rain. So now we'll calculate what angle he has to hold the umbrella. Now you will say, looking at the rain is coming downwards, I will hold it straight. But think practical. Suppose if you are traveling or riding on a bike, or someone is riding and you are sitting behind. Okay. Have you seen anyone holding it straight up, the umbrella? No, definitely not. You must be holding it slightly bent. Now that doesn't mean the rain has started coming slanting towards you. Okay, for you, because you are moving at 30 kilometers per hour, it looks like the rain is falling slanting towards you. That is the relative velocity. That's why you have to hold slightly at an angle. Otherwise, if you hold it straight, it will fly away. Okay, it will become reverse, ulta. The moment you stop your bike, again you cannot hold it slanting because the relative velocity will change. If you keep your this fixed, no, then it will be like a first case. You'll have to hold the umbrella at 90 degrees. But if you're moving at certain speed, then the angle will change. You will calculate it. So first we have to calculate the relative velocity. So V, same formula, VRG minus mel, okay, velocity of rain with respect to ground. So same like previous one, this fellow is coming downwards. So this will be minus 40 J cap because vertical, no, towards negative y axis. So that will be J cap. For y means always J. X direction, if it is moving, it will always be I cap. Now, can anyone tell me what is relative velocity of man with respect to ground in terms of Ij also? Vector form. What is velocity of the main now? Is it 0?
No.
How much it will be?
30.
Yes, 30 plus 30 actually it is, because he is going in the positive x direction. Now already as per the formula it is minus, but the main one is 30. But minus into plus will give me a minus. That's why I'm giving like this, because later you will not know why I used that minus. You may think I used minus for this fellow. It's not, it's already plus, but because of the formula it will become minus. So this is your velocity of rain with respect to main. So we'll plot it on the this diagram. So this is minus 30 means this side it will be and minus 40 means on the negative y. Now these two vectors. So the main vector, these are your components. So the components will have always a main vector. So we'll see what is the main vector of it. So obviously it will be between this and this. At which angle we don't know. So we'll just put it as theta. Okay, so we'll just put this as theta and calculate what is the angle. We'll just complete this and see. In order to calculate the angle, we'll use tan theta formula. Tan theta is opposite upon adjacent. So which is the side opposite to this? This one. If this direction, if this much is 30, obviously this fellow will also be 30. And if this is 40, then this will also be 40. Opposite sides are always equal. So this is 30, this is 30. So what it means is 30 upon 40. Here no need to put I and J, because I and J will only indicate the direct. So we are just calculating the angle. So it's nothing but opposite upon adjacent. So tan theta is 3 by 4. So theta is tan inverse of 3 by 4. Otherwise you can remember this. If theta is no 37 degree, I've given you a triangle. This is 3, this is 4, and this is 5. It is always 37 degree. Looking at this also, we can come to know whenever you get 3 upon 4 as an answer, tan theta is 3 by 4, automatically get. Otherwise you can calculate normal way. They'll give mostly like the standard angles only. We have already know to calculate. 37 degree. These are fixed triangles. Whenever this is 3, this is 4, this is 5, angle is always 37. So now this is at 37. This is our velocity of rain with respect to main, your common one. Now the umbrella has to be held exactly in the opposite direction. This is same as your theta. So the angle will remain the same. So this is your umbrella. So you have to hold the umbrella 37 degrees.
Teacher, can you explain the diagram?
Now this is your component. You have to plot the components because it is minus. Came here, this is minus. Now these are the components of your main velocity of your rain with respect to main. So we are calculating at what angle like your rain looks like to you, or where, at what angle the rain is looking at you with respect to each other. So when you calculate this as per the diagram, your angle is coming like this, theta. Okay. Now this is your velocity vector of your rain with respect to main. Now I told you starting only I gave you have to hold the umbrella exactly in the opposite direction of your velocity of rain vector. So with this side was your this, exactly in the opposite side you have to open up the umbrella. It's like right now if you do parallel shifting, it's like your rain is coming at almost like this angle. That's why you have to open the umbrella like this. And alternate angles. These angles are always same. This you already got as 37 degree. Obviously this also will be 37 degree. So this is like a man, suppose if he's standing, then you have to fold the umbrella at 37 degree. Understood now?
Okay, teacher, thank you.
So this is like a rain. Now just because we are representing in the graph, it comes downwards here. If you try to look practical, it's coming at this angle from top. But actual on the graph, it's like, because we have to show it negative and negative. And then the umbrella will come. So it's like over here, somewhere here. If this is a rain, then the person is standing here, then the umbrella will come here. It's parallel shifting. One more problem, similar one. This is coming at 60 degree, 60 kilometer per hour on a trolley, which is going at 80 kilometer per hour. The man is standing here. Calculate the angle. At what angle the man will hold the umbrella? It's moving, huh? Same like previous only numbers are changed. So your first thing is always to calculate your velocity of rain with respect to man. That is Vrg minus Vmg. Velocity of rain with respect to ground, it is coming downwards in the negative y-axis direction. So that's why it will be minus 60 j cap. This is already minus. He is going in the positive. Suppose if he was going this side, then it would be minus, and minus into minus would give me plus. Now represent this vector. These are your components. So I have to find which is the main vector and the angle between. So this is around 60, like 60 units. Then mark here. This is 60. Same way this is around 80. So I cap is this side, no? So this will be 80. And negative 60 will be here. J always on the y-axis, I always on the x-axis. Y minus because negative x-axis, and this will be plotted on the negative y. If this was plus, then you have to plot it on the positive y this side, and then the arrow would come. And now it is here. So somewhere between these two vectors, your main vector will come. So same way, take this angle theta. You have to take this as your theta, not this one. So that accordingly, this alternate angle comes here. And now calculate. So tan theta is directly this upon this. Calculate, complete the diagram. So this is 80 and this is 60. And this is a theta. So tan theta is always opposite upon adjacent. The opposite side is 80, adjacent side is. So whenever tan theta is 3 by 4, it is 37 degree. When tan theta is 4 upon 3, it is always 57 degree. So theta will be directly 53, sorry, that is 37, no? So complement range. Just correct it, 53 degree. Now can anyone tell me which angle the man will hold? What is the angle? In which direction? On the opposite direction. This is your main vector, so this will be 50. This will be on. If you want to represent in terms of north, south, if you are asked to do, then it would be north, south, east, west, and in northeast direction. And suppose, just in case, speed is also asked. Okay, what is the speed? Relative speed. Then you have to always convert this in terms of magnitude. Okay. Suppose magnetic speed has been asked. Then just find magnitude of, and then calculate. Next question. Now suppose rain is falling at an angle of 37 degrees, 50 kilometers per hour. And there's a man moving at 40 kilometers per hour. Calculate the angle. At what angle the man will hold the umbrella? Now, the rain itself is falling at 37. So whenever there is an angle, okay, there will be always component. You know, this velocity vector is slanting. Previously it was straight. So it was straight away j direction. Now it will have x component as well as y component. Okay, so whenever this fellow is there, so how it will look? If this is falling at 37, then it will always have a x component and a y component. So this is 50 kilometers per hour. Now it will have v rx. You can just consider as that is if your velocity of rain is this. So this will be your vx component and this will be your y component because it is at an angle of 37 degrees. To calculate the angles now, this will be how much it will be. Velocity of rain we have to calculate to 50 into cos 37. Use the triangle method and find cos 37 quickly. This is a fixed triangle which you have to know. So cos 37 is always 4 by 5. And sin 37 is always 3 by 5. Opposite upon hypotenuse. This will be 40. This will be 30. So your horizontal component of the rain is 40 and a vertical component is 30. Now we'll write what is the velocity of rain, okay, with respect to ground. Now if it was straight away like this, previous problem what was happening, it was just like this. So we could take directly minus 40j. Now it has x as well as y component. So velocity of the rain main vector in terms of the two vectors will be vx plus vy, both the components. So that will be, this is in the positive direction, so it will be 40 I cap, and this fellow is in the negative direction, minus 30 j cap. This is your velocity of the rain with respect to ground. So we have to now calculate velocity of rain with respect to men. Rain with respect to ground. So that is how much? This was the main formula, but we did not know this, so I calculated this. 40 I cap minus 30 g. And velocity of man with respect to ground is simple. It's going only in one direction, horizontal direction. So it's going at 40. 40 I cap minus 30 j cap minus 40 I cap. So this and this will cancel. So there is only one component, minus 30 j. The answer is, plot it on this. So minus 30 j cap will be in this direction. So your umbrella will have to hold exactly in the opposite direction. Angle of 90 degrees. Why there is no slant in this? There is no I. There is no result. This there are no two components. Directly just J. Only one you have to plot. Suppose if there was X also this side, then you have to find a middle this of both the components. But now there's just one component that is on the negative Y axis. So straight away umbrella will be opposite. No. Last one. This is 53, 50 kilometers per hour. And this one is also at an angle. It is moving on an inclined plane now. This is called as an inclined plane. So we'll have to find separately velocity of rain with respect to ground, velocity of man with respect to ground, because both are having components now. Both are at angles. So here first we'll calculate velocity of, because finally my formula is with respect to man. So Rg minus V with respect to ground. But VRG we don't know, because right now directly we cannot say it is 50 kilometers per hour, because it is at an angle. If it was straight downwards, then we would know. Angle means we have to find a component and then put. Here also, this is also inclined now. So we have to first find the two components and then put. So first I'll find what is velocity of rain with respect to ground. So for that, let us find a component. Let's just take one line. So this will be your x component. This will be your y component. Whichever is there attached to the angle, the axis 50. Yes. So Vx will be V cos of 57. V is how much? 50. Again, whenever 57 also, I told you the table. This is 4, this is 3, this is 5. So cos 57, or is this 53? Again, I missed. That is 37, this is 53. Cos 53 is 3 by 5 and V by 4 by 5. So it will be ulta now. Your Vx will be 30. Your Vy will be 40. So total velocity of rain with respect to ground will be. Now tell me the direction. So this is 30 and this is 40. Now tell me the direction. Plus I, minus I, whatever. Add both the components. Tell me the answer for this. What is your Vx? Whether you have to take plus, minus, I cap, J cap. Frame this and tell me. Component I found out. Vx is 30. Whether I should take plus 30, minus 30, I cap or J cap. Look at this diagram, which axis it is on, and tell me.
Minus 30.
Yes. And I cap or J cap? X, X direction means X is for who?
I.
Yes. X means always I and Y means always J. Is on this fellow, Vx is on the negative X axis. Negative X axis means I, and this fellow is on the negative Y. So this is your velocity of rain with respect to ground. The same way we have to find components for this fellow. Now your main vector is this side. So there will be always for the vector one horizontal. So this is already there, horizontal. So this will be a horizontal, vertical. This is Vx will be 37. Sorry, what angle it is going? This is 100. So this will be 100 cos 37. Your mean V is 100. And Vy will be 100 sin 30. So cos 37 is 4 by 5. This is 3. Now calculate. This will be 80. Will be 60. Now both are positive. Look at the main graph. Just compare it with the main graph. This is a positive x-axis. This is positive y-axis. This arrow is going on positive side. This also is going on the positive y-axis. So both will be plus. So velocity of main with respect to ground will be same. Vx plus vy. This component plus this component. So 80 I cap plus 60 j cap. And now the main velocity of rain with respect to main. This is already minus 30 I cap minus 46. Middle sign is minus. This is this fellows. And this one is this middle sign is minus. Put it in the bracket because this minus belongs to all the term. This minus is because of the formula. So minus 30 I cap minus 40 j cap minus 80 I cap minus 60 j, because minus into plus will give me minus. This is minus 110 I cap minus what 30 I and 80 I. This and this you have to add. This and this. Minus 40 minus 60 will give 100 j. If you plot it, both are negative. This will be minus 110. This is 110 and this is 100 j. Vector will be this side. You have to calculate theta. So tan theta will always be 110 upon 100. One 1.1. Theta is tan inverse of 1.1. Whatever you get will be your angle here. Just calculate arc tan of 1.1 and write. So that will be your angle in terms of degree. So the man will hold the umbrella at that particular angle. I'll stop here. Next week I will solve the question papers of all the 3 chapters.